Every mathematical model comes with a set of assumptions. For instance, if you're told that a surface is smooth, you need to know what assumption that you are making about that surface is. Today we're going to cover pretty much all the ones you'll need to know this year. Let's go through the common models and assumptions you'll be using in mechanics. A particle is a simplified representation of an object that has mass but negligible size and shape. Because it doesn't have dimensions, the only forces that apply to it are in relation to its mass. A rod is similar to a particle but has one dimension. Its mass is distributed along its length, and because it only has one dimension, it has no thickness. It's also rigid, so it doesn't bend. A laminar is the same as a rod but with a second dimension. A uniform body is a model that assumes that the mass is distributed evenly. This means you can find the centre of mass by finding the geometric centre of the object. A light object is assumed to have zero mass. This is great when modelling pulleys, levers or strings to focus on the dynamics of the larger masses they are connected to. An inextensible string is a string that does not stretch. The model ensures that the acceleration of connected objects is uniform, simplifying the equations of motion. A smooth surface is modelled to have no friction. If a surface has friction, it's a rough surface. A wire is like the metal wire you know, but is treated as rigid and one-dimensional. A smooth and light pulley has the smoothness, meaning no friction, and the lightness, meaning no mass. A bead is like the bead you know in the real world, which will thread onto a wire or string, but this one can move freely. It's also useful to attach objects such as wire and string, so we use pegs. These are similar to particles and have no dimensions and are fixed. Air resistance can be very difficult to work with in mathematical models. For many situations, its effects are very small, so we normally treat it as negligible, meaning we ignore it. It is assumed that all objects with mass have gravity, and that gravity is uniform and always acts vertically downwards. We almost always assume that g is 9.8 meters per second squared. If you are studying physics, this can be different to what g is rounded to there. Let's go through these questions. If we're assuming that the surface is smooth, then we're ignoring friction between the block and the table. If we model the block as a particle, it means that it has mass but doesn't have any dimensions. That means that rotational effects of external forces and the effects of air resistance are ignored. If we model the string as inextensible, it means it won't stretch, and the acceleration is the same for the block and the person or machine holding the string. Let's finish on this question. If I pushed a block on a smooth surface of infinite length, when would it stop? Let me know your answer in the comments below. And also come to onmaths.com or click the link in the description. You can access all of our A-level papers and predictions for free. You can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.